Hello everyone and welcome back. My name is Mr. Kovalt, and in this video we're going to talk about ordering bond links or bond orders. So let's get into this. So in this problem we're asked to rank the following species in order from shortest to longest nitrogen-oxygen bond and then explain. So the first thing we want to do is write out the Lewis dot structures for each of these species. So here we have H2NOH, and we're told that this is the bonding of the molecule. So if we do the Lewis dot structure, it would look like this. So we have our NO, and then H is bonded there, and this is going to have two hydrogens bonded to it, like so. We have our lone pairs there, lone pairs there. And so that's the Lewis dot structure for this one. Now for HNO, we're told that the central atom is N. So for this one, it's going to be H, N, and then here we're going to have a double bond O and lone pairs there. Okay, next we have NO plus. For NO plus, we're going to have N with a triple bond like so. And then finally, we have NO2 and NO3. And so those are going to look like this. So NO2, nitrogen bonded to two oxygens. One of them is going to have a double bond. We have our lone pair there. We have two lone pairs here, three lone pairs there. And because this has a charge on it, we have to have our square bracket. So I forgot this one here. So that's going to be positive. Okay, and so now we have NO3. So NO3 is going to look like this. So again, central atom is nitrogen. Oxygen is bonded to the nitrogen. We're going to have one double bond here. And then we're going to have our lone pairs. And so we have that as a Lewis dot structure. And of course, I can't forget, or shouldn't forget, the brackets with the 2 minus charge. Okay, so now that we have the Lewis dot structures, now we can calculate or determine what the bond order is between the nitrogen and oxygen. So here, you'll notice that there's a single bond between N and O here. There's no resonance possible. This can't change. We don't have any double bonds that can move around. So here the bond order between nitrogen and oxygen is 1. Okay. Again, here we have the nitrogen-oxygen bond. Here we have a double bond. And again, that double bond can't move. It's not going to go anywhere. So we don't have resonance in this molecule. So the bond order between nitrogen and oxygen is going to be 2 because it's a double bond. So the bond order is equal to 2 here. Once again, we have a triple bond between nitrogen and oxygen. So the bond order is 3. Here we do have resonance. This double bond can be moved over here. And again, remember with resonance structures, with resonance, it's not like this double bond actually moves, but it's that this double bond character is averaged evenly between the two oxygens. So again, when you calculate bond order, you divide, or you take the number of bonds and you divide that by the number of atoms that the bonds are between. So here I have 3 bonds. I have 1 single bond plus 2 bonds in the double bond. That's 3 bonds. So the bond order is going to be equal to 3 bonds over, and I have 2 oxygen atoms that are kind of sharing those bonds. So I'm going to divide it by 2. And so therefore the bond order is going to be 1 1/2. Okay. Now finally we have NO3 2 minus, our nitrate molecule, our nitrate ion. Same thing here. So this double bond has resonance. It can move around, but again, technically, it's not that the double bond moves around. It's just that the double bond character is shared evenly among the 3 atoms. So to calculate the bond order here, that's going to be the total number of bonds. So we have 1, 2, 3, 4. So 4 bonds divided by the number of atoms that are kind of sharing the bond. That this double bond is kind of shared among these 3 atoms. So we're going to divide by 3. So that's going to be 1 1/3 of a bond. Now that we have our bond orders, now we can use the principle that the bond order, the higher the bond order, if you increase the bond order, then you're going to decrease or shorten the bond. Lower bond order means longer bond. Higher bond order means shorter bond. So the higher the bond order, the shorter the bond. So we want to go from shortest to longest, right? So that means that if we're going to start with the shortest length in the nitrogen oxygen bond, then we're going to have to start with the bond order that is highest. So highest bond order is going to be this one right here. So this is going to have the shortest bond. So I'm going to have NO plus. So NO plus is going to have the shortest. So that's going to be less than. And next, what's the next highest one? We have 3, 2, right? So 2 is going to be HNO. So HNO will have the next shortest bond, or the next longer than NO plus. So then now we're at 2. What's less than 2? Well, we got 1 1/2 and 1 1/3. 1 1/2 is larger than 1 1/3. So this is a larger bond order, meaning that it's going to have a shorter length compared to this one. 1 1/2 is less than 2, right? So that means that this would be next in line. So that's going to be NO2 minus. And then next, the next smaller bond order is going to be 1 1/3. So that's going to be this one. That's going to be a longer bond length. So that's going to be NO3 minus. And then finally, number 1, this is going to have the longest bond length. So that's going to be NOH2 NOH. And so that would be the order from shortest to longest in bond length. And so that is how you determine the order of bond length based on the bond order, and you get the bond order from the Lewis dot structures. So I hope this is helpful. If you enjoyed this video, if this helped you in any way, then please, by all means, like the video, share the video, hit that like button somewhere over here. Also, do me a solid, show me some love by subscribing to my channel. Hit that notification bell. And when you do that, make sure you click all so you'll be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a problem or question that you need help with, or a topic you would like me to cover, write that down below. I would love to do that for you. Thanks for joining me, and have a great day.